Thank you. So let me see. I'm the tech guy here, so presumably.
You're set.
So how do we switch slides?
You just go arrow down.
Arrow down. That's what I was going to do.
All right.
So I was at an event last night, which was a lot of fun, with Senator Gardner from my home state of Colorado and Senator Flake. And Senator Gardner said that, he couldn't believe that they were friends given the long history of Arizona trying to steal Colorado's water. And Senator Flake said, yeah, but that water's flowing south, so maybe that's where it really wants to be. Water has been, I cover a lot of issues for Intel globally, but water has been a big part of my career, from my first job in college at the Denver Water Board to most recently working on water quality issues with a conservancy group in Annapolis working on the Chesapeake. Certainly for Intel, water is a big component, a big factor of our productivity. And I just wanted to start with a little bit about our bona fides. We just announced last week out in California a huge new initiative to achieve 100% return or restoration of the water that we use in all of our facilities in the U.S. We're starting in Arizona at our facility in Chandler. We're one of the biggest, if not the biggest, private employer in Arizona. We're going to spread that over time to our facilities overseas. Historically, we have conserved about and restored about 80% of the water we use. And in 2016, we conserved 4.2 billion gallons of water. That's about 7,000 Olympic-sized pools worth of water, just to put it in context. To go to 100% restoration, we are going to do a combination of doing more within our own plant gates, within our fence line, but also we are going to be working with the communities in which we operate to help others, including both industry and agriculture, become more efficient. And so it's going to be a systems approach, not just limited to our own facilities. And we're going to be working with a variety of NGOs in all of our locations, particularly Arizona, New Mexico, and Oregon, to achieve that goal. So this is a wafer. All those little rectangles or squares are individual CPUs. I think most everybody here has heard about Moore's Law, the packing of more and more transistors and achieving lower and lower price points. We put billions of transistors onto each of these little rectangles, and the way we do that now is to some extent by shrinking the feature size, but more recently by adding layers. So this disk with the chips that are still attached has gone through multiple dozens of process steps, and at the end of each of those process steps, typically there's rinsing with water. So that's the principal way in which we use water in our facilities, is cleaning, some for cooling, but mostly for cleaning. And most of the water that leaves our plant gate actually is cleaner than what came in the front end. And that's because we spent a lot of money on the front end, taking much of the water we use, at least the water we use in our process steps, and turning it from pure water to ultra pure water. And so there's a lot of energy expended in that. But as I say, most of the water that leaves our facility is cleaner than what came in. Now, this is a really bad panoramic picture of our Chandler facility. There are three factories, 1, 2, 3. One is not yet operational. This facility, the third facility, I think the one on the left, was built a couple years ago. I was there in the middle of the construction. They rented what was the largest construction crane in the world, called Big Blue, which travels around the country and rents out or rented out then for $500,000 a day. So you get a sense for the scale of the construction. What you see in front are all the solar arrays that cover the parking lots. We've installed at all of our U.S. facilities and a lot of our international facilities, very large solar arrays. Now, the one thing I should say is we are kind of bipolar when it comes to where we locate our facilities. Our major manufacturing facilities are either in very arid places like Phoenix and Albuquerque, or in very water-rich areas like Portland and Ireland. Another arid region where we are a big employer is Israel. So, but even in the places like Oregon and Ireland, water is important, and it's not just water quality, but also concerns about water supply as communities grow. So this is a facility that's a big part of the water project that I just mentioned. This is a reverse osmosis facility that we invested $100 million in and turned it over to the city of Chandler. This handles a lot of our water. It handles water from other facilities in Chandler, and its purpose is to restore water quality and to return the water that goes through this facility into the aquifer for storage for future use. We're very tight-lipped about who our suppliers are, but trust me, there's a lot of GE water technology in that facility. So this is an example of where it's a combination of our own water and the community's water, where we're going outside our fence line to achieve our 100% restoration goal. This is, you know, I looked at this morning and I said, why the heck did I put this in here? This is the inside of one of our Chandler fabs. I can't even tell you what this is because I've not been to this particular corner. The point is, there are a lot of machines, very expensive machines that are involved in the manufacturing of semiconductors. The precision is something we have to go for. And there's a lot of water that are used inside those machines. I think also increasingly these machines are outfitted with IoT sensors that improve the energy efficiency, water efficiency, and productivity. And we think IoT in the future, in the whole realm of smart water grid, is going to become an important part of the story of water productivity here in the US and globally. Finally, starting in Arizona, we are going to be working with the Arizona Land and Water Trust on a couple of different types of projects to improve the water efficiency of agriculture in Arizona. One is conversion to products that are lower water intensity, and the other is to use the water that is required in a more efficient manner through the use of sensors embedded typically in the soil. We're also doing some projects with improved irrigation efficiency in Utah and communities where we're present as well. And this is another area where IoT is going to play a big role in the future of water resource management globally. Thank you.
Thank you.